and the other is what is the product going to be. So how do we figure out what the product is going to be again? So I'm going to take this potassium and this lead, and I'm going to switch them. Good. So that means that instead of potassium iodide, I'm going to have potassium nitrate. And instead of potassium lead nitrate, I'm going to have lead iodide. All right. So how we figure out whether or not these are aqueous or solid is by looking back at the solubility rules. So looking at the solubility rules, this one is not too bad because potassium and nitrate are both in the list of things that always dissolve. So those we can call aqueous right off the bat. So that's for potassium iodide. And lead nitrate. And then potassium nitrate, those are still always soluble, so that's going to be aqueous. And what about lead iodide? Iodide was one of the ones that's not soluble and, well, that was soluble unless it was mixed with certain things. Was lead an exception, making it insoluble, or not an exception, making it always soluble? From the list we went over a minute ago.
Would it be like an exception because it's indissoluble?
Correct.
Okay.
Correct. So that's going to make lead iodide a solid. So let's see, we want to make sure everything is balanced. So I think I need a 2 here. Yep, that's right. Okay. So a lot of times these questions will ask things like, is there a reaction? So the way to tell is to look at the right-hand side and see if you have anything that's not listed as aqueous. So here we have a solid. So that's not aqueous. So that means it's permanently bound in that it's not going to dissolve in water. So that means there is a reaction there. All right. So let's see what happens when we have a different kind of reaction, one that everything is aqueous.
If it's like all aqueous, it wouldn't be on the chart. Is that correct?
It'll be on the chart.
Okay.
Hang on just a second, and I'll show you.
Okay.
All right, so if I hadn't told you what the products were, you could figure them out because all I did was switch the potassium and the sodium. And then to figure out whether or not they're aqueous, you can look at the solubility chart and you'll see that sodium is always aqueous and so is potassium. So that's going to make both of those always aqueous. Chlorine is always aqueous unless it's mixed with certain things. And potassium isn't one of them because potassium's always aqueous, always soluble. And then sodium's also always soluble. So all of these things, since they're soluble and would have been listed as blue, that means they're aqueous. So looking into it a little deeper to figure out what happens in solution, we would start by separating everything out to get the overall ionic equation. So that's where we're going to separate everything that has an aqueous symbol. If it didn't have an aqueous symbol, we wouldn't separate it. I wanted this little aqueous symbol at the end. Oh, golly, there's got to be an undo button for that. Okay, I'll just leave it like it is. And we'll just know that I minus is aqueous. The aqueous just went down to the wrong row. All right, so we're looking to see, to get to the net ionic equation, we get rid of all the spectator ions. A spectator ion is going to be something that looks the same on the left and on the right. So potassium is aqueous on the left and is aqueous on the right. Iodine is aqueous on the left and on the right. Sodium is aqueous on the left and on the right, and so is chlorine. So in this case, if we were to write the net ionic equation, all we'd be left with is an arrow, right? There's nothing left. And that means that everything on the left is identical to everything on the right. And what that means is that there was no reaction. And if I was asked to give the net ionic equation here, I wouldn't draw the arrow. I would just say that you can't, because there is no net ionic equation, because no reaction occurs. A lot of times what people will do when they write the equation out, they might do something like this: Ki aqueous plus NaCl aqueous. And once they find out that no reaction happens, on the right-hand side, they literally just write no reaction, like that. On SmartWork, I don't know if it wants you to write no reaction or if it wants you to write out what it would have been if there was a reaction. But this is the kind of thing that would not have a reaction. There's another thing I wanted to show you, and that's how to break apart things that have subscripts and coefficients and things like that. So any questions over the last one